Hi, welcome back to your new lesson. This is Lakshmi Tiwari. In this lesson, I'm going to show you how you can build your own convolutional neural network for detecting a credit card transaction fraud. And the data is available at kaggle.com. This is quite large data set, so I cannot upload this on my GitHub repository, but you can download this data set from here itself. And you can also go ahead at my KGP Talkie channel and you can watch previous videos on a deep learning with the TensorFlow 2.0. So in this, I'll be showing you how you can build a convolutional neural network and how you can add max pool, dropout, batch normalization, etc. to improvise your accuracy. And then I'll be showing you how you can achieve accuracy of a 91.37% by adding a max pool, and without adding a max pool you can achieve accuracy of around 92%. And apart from that, I'll be showing you how you can also plot a learning curve, and with this learning curve how you can understand whether your model is overfitting or it is underfitting. So without wasting a time, let's go ahead and start a step-by-step lesson for a credit card transaction fraud detection using convolutional neural network in TensorFlow 2.0. Alright, so in this lesson we will be working on a credit card fraud detection using a convolutional neural network. It was a competition, it was run at kaggle.com, and there you can see it has a data of 66 MB and it provides a credit card.csv file for our purpose, which has 31 columns. In those 31 columns, 30 columns is for a feature and the last column is for whether the transaction from a credit card is genuine or legitimate or it is a fraud. And you see here it has a huge, actually, the number of rows, that's mean the number of data is huge here. That is 285,000 number of rows. Alright, so this data set was released in September 2013 by a European company, a European bank, and the personal information was hidden, and it is given there the top 30 principal components from original data. So in no way we can know the persons whose data is who. All right, so all over this data is completely the anonymous data, and in this we are going to apply convolutional neural network to detect a fraud if there is any fraud. But the question comes here, you see it has, although it has 284,000 transactions, between that transactions there is only 0.17%, which is around 492 transactions. So out of these 284,000 transactions, there were just 492 transactions were fraud. Alright, so you can say that the data here is highly unbalanced. That means we also need to balance this data for a better prediction. Otherwise, in unbalanced data set, the predictions, the machine learning algorithms try to overfit to those data set whose number of levels are higher. Alright, so let's go ahead and start this new lesson in a Jupyter notebook. You might be remember that earlier I have been working on Google Colab notebooks because their convolutional neural networks were really needed a GPU, but for this credit card detections we don't need any kind of a GPU. A CNN can run on a simple CPU for a credit card fraud detection. Alright, so if you don't have a TensorFlow installed in your computer, you can install a TensorFlow GPU, okay, beta version, and you can also get updates of a latest version at tensorflow.org. But before that, you need to also download the CSV file. You can download that CSV from here. Click on download, and here you will get a download a credit card for CSV.zip, and once you extract this, you will get a CSV file. So here I already have that CSV file. Let me show you that I have inside here. So I already have that credit card.csv file, which is 147 MB large, and I have created here a file, credit card transaction fraud detection using a CNN, and it contains here credit card.csv and the original file. Alright, so let's go ahead and first import a TensorFlow as a TF and a keras from a TensorFlow. and a sequential model from a TensorFlow keras, and flattened dense dropout and batch normalization from layers, and of course the convolutional 1D and the max pool of 1D. And here we are printing a current version installed, current version of a TensorFlow which is installed in my computer. It should print 2.0.0 RC0, which is release candidate 0. Alright, so it is taking a little time to import all these packages in Jupyter Notebook, and yes, it is TensorFlow 2.0 installed in my computer. Now let's go ahead and import some necessary and supporting other libraries. So here we have got supporting libraries as well. Now let's go ahead and read our credit card.csv using pandas data frame. So we are going to read that into a data, and there we can get with the data dot read CSV, and in that we can get with credit card.csv. Alright, so let's go ahead and print the few lines of data that it will show us 5 lines and 31 rows, 31 columns and the 5 rows. So in these 31 columns, you see the last column shows that whether a transaction is fraud or it is legitimate. Alright, so let's go ahead and see a shape of this data. How much data we have? We have total 284,807 rows and just 31 columns. Now what we need to do, now we are going to see if there is any null values present in this data. And to check that null values, what we can do here, we can just say that data is null and sum. So with this we will get if there is any null values in any column. It says that there is no null values in any column, so we are safe to go ahead. Now let's go ahead and see other information of this data. It says that all the values are float 64, I mean the feature space are 64, and the output, which the target actually, that is int 64, so nothing to worry about that. Now what we are going to see here, we are going to see here how many the classes are in actually class 0 and 1. I mean, to do that, what we can do here, we can say here a data class, then dot value counts. So it says that there are 284,315 transactions were legitimate and just 492 transactions were fraud. So this is a case of highly imbalanced data set. Alright, so we need to do some data processing to balance this. So let's go ahead and give a name like balance data set. So we are going to here balance this data set. So first of all, we are going to get the data frame of non-fraud. Okay, so legitimate actually. So non-fraud, in non-fraud, how would you get that? So the data inside a class which is equal to 0. So non-fraud, and similarly we will get a fraud. And if you see here inside a fraud, and we are going to see all classes which is equal to 1. Alright, so with this we have got a fraud and the non-fraud. So let's go ahead and get the shape of fraud and non-fraud. So in this we get here for a fraud data frame, we have a 492 rows which is actually a fraud, and this is for non-fraud. Now what we need to do, we need to select just 492 rows from this non-fraud data frame, and those selections should be random. And for random selections we are going to utilize a sample from a pandas data frame. So we are going to say here a non-fraud is equal to non-fraud dot sample. So it will select random samples, and how many samples we want? We want total fraud dot shape, and inside the shape we want 0, that is 492. So in this we will also get non-fraud with a 492 rows. Alright, so now fraud and the non-fraud has been came into a same, I mean now it is a balanced data set. Once these fraud and non-fraud is balanced data set, now we need to merge these two pandas data frame together. And to merging these together, what we can do, we can say here a data is equal to, so I'm gonna append inside a fraud. So we can say just simply fraud dot append, and inside that I'm gonna append non-fraud, and I'm also going to ignore the indexes. And now let's go ahead and see data. So now you see this data contains 984, which is just 2 times of 492, and it has 31 columns. So we have got here a balanced data set. And similarly, if you check here a class, inside this, here you see a fraud transaction 492, and legitimate transaction is also 492. All right, now we have got it. Now what we need to do, we need to do a train and test split. But before that, let's go ahead and get a feature space. So a feature space X is equal to a data, and then we need to just drop here a class, and that will be dropped at axis 1. And similarly here we have Y is equal to data, and then we here have a class. All right, so we have here X and Y. Now what we are going to do here, X underscore train, and here we have X underscore test, Y underscore train, and then Y underscore test is equal to train test split. And inside that we have X, Y, and then here we have a test size, all right, which is 0.2, that is the 20%. And then here we have a random step which is equal to 0, and then I'm gonna also stratify this according to Y. So we have got here training and testing data set. Let's go ahead and check the save of X train as well as save of X test, I mean the test data set as well. So here we have a 787 rows for training and 197 for testing data set. All right, so let's go ahead and print our training data set. So in a training data set, you see the scaling of these values are pretty much different. That means variance is too much high between these columns. So what we need to do, we need to do here a standard scaler. So what we can do, we can just call here, I mean we need to standardize this data. We can do that with the standard scaler is equal to X underscore train is equal to scalar dot fit underscore transform, and inside that we need to pass here X train. And then for X test we need to pass here scalar dot transform. Do remember, I'm not going to do here a fit transform, but instead of that I'm going to do here transform, and there I need to pass here X test. So by doing this, it avoids overfitting. All right, so we are transforming X test based on the findings of X train. That's in the training set. Now after this, we are going to convert our the Y data set, which is actually Y, the training and the testing label, into a numpy array, so that we can do Y train dot to numpy, and similarly for Y test is equal to Y underscore test dot to numpy. All right, so we have here X train test, Y train, and the test into a numpy array. Now we are finally ready to reshape our the parameters so that we can build our convolutional neural network. Since convolutional neural networks during the training takes a 3-dimensional input, and if we check here our X underscore train dot shape, it has just a 2-dimensional of the data. That's mean we are going to add here a 3-dimensional. So to do that, what we can do, X underscore train is equal to X underscore train dot reshape. All right, so I'm going to reshape this into X underscore train dot shape, and for that at 0th. All right, so that is 787, and similarly x train dot shape, and here we have 1, and then finally 1. All right, let's go ahead and copy and then paste it here, and then finally similarly we are going to do for x test as well, and to do that here. All right, so the training and the testing data set is having a same dimension, so nothing to worry about that. Yes, definitely there is problem. Actually we need to do here x underscore test, and here x underscore test as well. All right, so now the reshaping is done. Now if we check the shape of x train and shape of x test, we will get a 3-dimensional data. All right, so now we are ready to build our convolutional neural network. Let's go ahead and write here build CNN. For that I'm going to define here number of epochs is 20, and then model I'm gonna get a sequential model here, and inside that I'm going to first add our convolutional neural network, 1D convolutional neural network. And in that first it asks about, if you press here shift and the double tap, it asks about how many number of filters we want, and then the kernel size and activation functions, etc. So the number of filters in first layer I'm going to give 32, and kernel size I'm going to provide 2, and the activation functions I'm going to provide here a ReLU activation function. All right, and for a first layer of convolutional neural network we also need to provide input shape, and here input shape we are having x underscore train, and for first row shape. All right, so with this we get here our first layer of convolutional neural network, and then after that I'm going to add batch normalization. All right, so we have added here batch normalization, and then after that I'm going to add here just a dropout. All right, so after this we have added here a dropout and batch normalization, and now this is the first layer is ready, and we are not going to add here a max pool. I'll add that later. Now let's go ahead and add here the another layer, and in the second layer we actually do not need the input shape, so we can just remove input shape, and number of units I'm going to pass here 64, and I'm going to increase a dropout from 0.2 to 0.5. so in this way 50% of neurons will be dropped after second layer, and 20% of neurons randomly will be dropped after first layer. So now I'm going to convert this the 2-dimensional or multi-dimensional data into a vector. That we can do with a flattening layer. So here we have a flatten, and then similarly we have here model dot add, and then here we have dense layer, and inside dense layer we have 64 units, and then here we have activation function which is actually ReLU. All right, so here we have add dot dropout and then 0.5. all right, and then finally model dot add, then here we have a dense 1, then here we have activation function of sigmoid. All right, so with this, if you see here we are building actually binary classification. That's when we are detecting whether transaction is fraudulent or it is legitimate transactions. That means we only need to give here just a single unit that can represent either 1 or a 0, and since this is a binary classification we need activation function of a sigmoid. Let's go ahead and run this. So our model has been built. Now let's go ahead and get a summary of our model, and in the summary we get here 119,000 parameter. All right, so after this summary let's go ahead and compile this model. We can compile it by passing model.compile, and there we need to pass here optimizer, and in that I'm going to pass here ADAM optimizer with learning rate of 0.001. all right, and then I'm going to pass here a binary cross entropy loss function. all right, and then here metrics, I'm going to pass here accuracy. So our model is it says that ADAM is not defined because we have not imported ADAM, so we can import that from TensorFlow keras optimizers import ADAM. all right, so let's go ahead, come here, and our model has been compiled. Now we have reached into a most exciting step, which is a training of our model. So with this we can get with history is equal to model.fit, and inside that fit I'm going to pass here x train and then y train data, and the number of epochs which I had defined that is 50 actually. And after that I'm also going to provide here a validation data, that's in the model will be also validated on a testing data set x underscore test and y underscore test. And the verbose I'm going to set here 1, that's mean it will be also printing, it will be printing the progress of training, right? So you see here the training has been started, and it says that we have been getting in a first step training accuracy 66%, but validation accuracy is 87%. But if you see at the end of the 20 epochs, we have got here a validation accuracy of 91.88% and training accuracy is 93.52%. That's mean there is some difference between training and validation accuracy. In that way we can say that our model is overfitting. all right, and to plot this I have already written code for plotting a learning curve, and if you don't know about that you can go ahead at my channel KGP Talkie. In previous videos I have shown learning curve plot many times, and I have especially covered a lecture on for plotting a learning curve, and a confusion matrix. Here you see lecture number 4, you can go ahead and watch that. So I have just copied and pasted it here. You see these two line of code here we are plotting accuracy and the validation accuracy, and here in these two lines we are plotting a loss of the training and the validation loss. all right, so let's go ahead and run this. After that we are going to pass here plot learning curve and the history of learning and then epochs, and then here the epochs. all right, so with this you see the validation loss is less than a training loss. Moreover, we can see here that loss of validation and training data set is meeting together, and something like here also as well. And we can say that our model is neither the much overfitting or not it is in underfitting. all right, so this is how we can build a credit card fraud detection using convolutional neural network. And apart from that we can also add here a max pool as well to understand how our model is getting the accuracy. And to do that what I can do, I can just copy this cell and then I can write here adding max pool and then paste it here. And after that I can copy this model compile as well as this model history. all right, and after that once that is done then I can also copy this model learning curve. all right, let's go ahead and put all these in a single cell, and now I'm going to add here a max pool. all right, so let's go ahead and add here a max pool 1D of 2, and similarly here I'm also going to add here max pool max pool of 2. Let's go ahead and run this model, and you will see here after 20 epochs accuracy has been decreased. All right, and so we can say that max pooling is actually not helping much to attain a better accuracy. But one more thing you can see, our model is still learning and validation accuracy is more than the training. That's when we can increase the number of epochs to see how it is increasing. All right, so let's go ahead and increase it to 50 epochs and see for 50 epochs whether we can reach a better accuracy or not. So it says that after 50 epochs, it says that after 50 epochs we reach accuracy 30 or after 30 or 20 epochs we reach accuracy around 91%, and same accuracy for our training and the testing as well. So you see after 20-30 epochs the training and the validation accuracy has the saturated. So with this we can say that with this convolutional neural network we can achieve 91.37% accuracy by adding pooling layer. But without adding a pooling layer we can achieve accuracy of around 91.88%, which is also somewhere a little larger than 91.37%. Alright, so this is all about in this lesson. Thank you so much for watching this video. Please do not forget to like and subscribe this channel so that you can get updates directly into your inbox. Bye bye, have a nice day.